day, everyone. We are now taking up the concept of understanding integers and absolute value. Objective here is this lesson focuses on the introduction of integers and the concept of absolute value using the number line. Okay. So we are now on the illustration of the system of real numbers, or we call it as real number system. Basically, real numbers are classified into two major classification, and that is rational numbers and irrational numbers. So we all know that rational numbers also classified into integers, whole numbers, natural numbers. And what makes irrational numbers different from rational? If you are dealing with a radical value, radical numbers which are non-repeating, non-terminating value, then that is an irrational number. Now notice that there are also radical numbers which is considered as rational numbers, just like a perfect squared radical number. For example, square root of 16 over 25 is rational in the sense that we can simplify it as 4 over 5. Okay, we will discuss more about its difference while we continue our discussion. Now, what is integer, by the way? Integer is any number from a set. An ellipsis of negative side. So start from -4, -3, -2, -1 to the negative infinity. And 0 serve as the middle number between a negative and a positive integer. So it is increasingly arranged from least value to the greater value. Now, what are they? So the greater value would be on the left side of, right side of 0, and that would be a positive numbers. So numbers on the right side of 0 are considered as positive integer. These numbers are greater than 0, written with or without a positive sign. So by the way, putting a positive sign to a number is optional. And the value increases as numbers move further from 0. Like for example, 1, 2, 3, 4 are the positive numbers because it's greater than 0. 4 ellipses. While negative integer, these are the numbers on the left side of 0. And notice that these numbers are less than 0. Can be written with a negative sign. So if it's a negative number, you should always put a negative sign to clarify its representation. Value, which means that value decreases as numbers move further from 0. So, example, we have -4, -3, I think it's ellipsis. Okay, so you have that as an example. While 0 is neither negative or nor positive. So, no need to put a sign. You're talking about a number 0. The positive and negative sign are symbols used to indicate addition and subtraction also. But in a number line, they indicated the direction of a point from 0 point as the reference point, not as an operation to be performed. So in the number line, positive and negative sign are used as a sign of directions. Thus, it can be read as positive 2, not plus 2. So we should be careful also in mentioning that plus and positive. So if you're talking about a number line, numbers in a number line, it should be either positive or negative. Do not mention plus, minus. Okay, a number line is a line drawn starting from 0 and which extends to both sides without ends. This means that there are infinitely many numbers on both sides from the origin of the number line. So from the origin of the number lines, which is 0, positively increase towards the positive infinity. And so in the left side, it is negatively decreasing towards the negative infinity. Okay, take note that the number line can also be drawn like this, show larger numbers. So a number line can be calibrated. It depends upon your assignment of numbers, whether you are increasingly it to have a greater value or a lesser value. You can project numbers in greater form or lesser form. So how to represent integers? In real life, there are situations where you can represent integers. Like for example, weight loss of 25 kilograms. So, in the representation as an integers, it can be represented by a number negative 28. Another example, an increase of 500 pesos allowance. So it is simply positive 500 or 500. Okay. Another altitude of 1,200 feet. So it is positive 1,200. Another situation, spending 500 pesos. So it can be represented by a negative 500 integer. for 12 steps backward. So it can be represented by negative 12. Now, comparing integers, you can always compare integers on the number line. An integer is always less than to the numbers on its right side and greater than numbers 2 on its left side. Which means to say that the right side numbers are greater than the value of left side numbers. So, an integer is always less than on the numbers on the right side and greater than the numbers on the left side. So, if we take into consideration its inequality statement about this, for example, we are using the dots in negative 4 and positive 4. So, if we compare these two numbers to 0, you'll notice that negative 4 is less than 0. Or, it can also be read as 0, which is greater than negative 4. Another example, you have the negative 6 compared to 2. So in this case, 2 is, negative 6 is less than 2, or 2 is greater than negative 6. Another example, comparing 3 and 5. So 3 is less than 5, or 5 is greater than 3. Ordering integers. You can also arrange integers either in ascending or descending order. So in ascending order, integers are arranged from least to the greatest, while in the decreasing or descending order, integers are arranged from greatest to least. So it is easier to arrange integers in order by plotting them on the number line. So, like for example, you are required to arrange integers of negative 1, negative 6, 4, 2, 0, and negative 3, and 5 in descending and ascending order. So, finally, we have 5, 4, 2, 0, negative 1, negative 3, negative 6 would be the descending order. And for ascending order, we have negative 6, negative 3, negative 1, 0, 2, 4, 5. Now, what is absolute value? By the way, another important idea to be learned from this module is an absolute value. An absolute value of a number is the distance on the number line between the number and 0. So, once you are comparing any number with respect to or 0 serve as the reference value, that would implicate to an idea of finding an absolute value. No matter what is the position, where is the position of that number compared to 0. Okay? So the number and 0 without any regard to its direction. So the absolute value of any number is a non-negative number. So that's why we can quantify it as distance with respect to 0. So absolute value implicates to a quantity. That is why it is always a positive value. For example, if you're required to find the absolute value of 5 and negative 5. So, as a distance, it is always positive. So, absolute value of positive 5 is 5. As well as absolute value of negative 5 is also equal to 5. Remember this. For any numbers of n, an absolute value of n if n is positive number, and 0 if n is 0, and negative n if n is negative number. So opposite integers can be the same absolute value since they have the same distance from 0. So as a quantity. Absolute value of one integer is always positive because there is no negative distance. Again, quantity is always positive in nature. Absolute value is denoted as, we have two vertical bars, a number between two vertical bars. The absolute value of 0 is 0. Example number 2. Find the absolute number of each. Now the absolute value of negative 27 and positive 27. So, as a quantified value, it is always equivalent to 27 units with respect to 0. Absolute value of 30 and negative 30. Again, it is equivalent to 30 because both integers are referred to 0. Quantifying its distance is always positive in nature. For letter C, what is the absolute value of 56? The answer is 56. Letter D, the negative of the absolute value of 78. Okay, the answer would be negative 78. Why? Because there is already a negative. That absolute value of negative 78 precedes a negative sign outside, so it is affected. So the final answer would be negative 78. In letter C, if you are, E rather, finding the absolute value of a negative 150, that is positive 150. Okay. F, negative absolute value of 98. So the absolute value of 98 is 98. But since the absolute value precedes a negative sign, finally you have negative 98 is the answer. So you're required to perform this activity as a follow-up task for you to apply what you have learned from the previous discussion. So it is letters A, B, C. Okay, D, including D as an activity. I think that would be all. This is your teacher, Mr. Cedric A. Borres. Thank you. 9 degrees, negative 210 degrees Celsius, positive 181 degrees Celsius, and 113 degrees Celsius respectively. So you are required to find, in letter A, the difference between the melting point of lithium and the melting point of nitrogen. So the melting point of lithium is equivalent to 181 degrees. That is to be subtracted by negative 210 degrees Celsius. So it turned out that the statement now becomes 181 degrees Celsius minus or plus 210 degrees Celsius. Again, there's a correction here. By distributing negative sign to the minus side, it becomes positive 210 degrees Celsius, which will be redirected, directly added by 181. So instead of 19 degrees, will you please correct it? The sum of 210 plus 181, so we have 391 degrees Celsius is the answer. For letter B, we are required to find the difference between the melting point of mercury and the melting point of nitrogen. So for mercury, we have negative 39 degrees Celsius to be subtracted by the melting point of the nitrogen is equal to negative 210 degrees Celsius. So that finalizing our statement, we have negative 39 degrees Celsius plus 210 degrees Celsius. Finding the difference between 210 by 39, final answer is positive 171 degrees Celsius. Letter C. Find the difference between melting point of lithium and melting point of mercury. So 181 degrees Celsius to be subtracted by negative 39 degrees Celsius. So negative times a minus sign, so it becomes a positive 39 degrees Celsius to be added by 181 degrees Celsius. Final answer is 220 degrees Celsius. Okay, perform the triad activity. I think that will be all. This is your teacher, Mr. Cedric A. Borres. Thank you and good day again.